All right, Bergson and the Holographic Theory of Mind, continuing part 50 on Joscha Bach and Joscha's AI worldview, where mathematics is the foundation of the universe, and thus computation is the basis for consciousness, when in fact the inverse is true. Consciousness is the basis of computation. But in Joscha's view, virtual reality then explains the hard problem, dualism, idealism, etc., etc. Common sense knowledge, well, this is no problem. The image of the external world, we insert some magic. The origin of consciousness, insert more magic. Continuity of the self, and more magic. And time, the problem thereof, well, it doesn't exist. So let us see. Sollux Freeman, AI, MIT, has interviewed a long line of physics and AI luminaries. Virtually each could be, shall we say, a bit harshly examined from the Bergson perspective. But his recent video with Joscha Bach, we've got to take a look at, because things have gone just a little bit far, shall we say. This is AI with its completely unexamined metaphysic, with the non-examination of its unexamined metaphysic, its complete lack of awareness of this running wild. And judging by the huge number of approving comments, AI folks really buy this. AI folks need, please, to add some intuition. As the rat says, preferably Bergsonian. Joscha Bach, Vice President of Research at the AI Foundation, not sure what that is. Previously did research at MIT and Harvard. PhD in Cognitive Science from the University of Osnabrück, Germany. Built computational models of motivated decision-making, perception, categorization, and concept formation. Was especially interested in the philosophy of AI and in the augmentation of the human mind. Now, Lex's interview format obscures JB's actual model of mind. The story, the view, the framework unwinds slowly, a bit foggily, a bit difficult to see clearly, but we'll look at chunks of the interview, and we'll switch to an FQXI presentation 6 months earlier in December 2019. For here, when fog is stripped away, the magicians hiding everywhere come out to play more clearly. Now, sorry, this model of mind is itself an AI illusion, so I'm being a little bit direct here. So the foundation in Joscha's mind is math. Lex starts the interview with an amazing question. As he says, why does anything exist at all? Actually, it's about 12 minutes in. Why does anything exist at all? Joscha, or JB, as we'll say, he says the easiest answer is existence is the default. The lowest number of bits you would need to encode this. Now, instantly, we hit the AI mythology of bits. Apparently here, just like Leonard Susskind, eternal, 5 physically impervious bits. That is, they're impervious to any kind of physical processes. They exist no matter what. In reality, at least in all current implementations, the 10 bit is an abstraction. It exists as some arbitrary state, say 5 volts or 7 volts, maintained over an electromagnetic flow, sustained by a complex electromagnetic structure, very complex electromagnetic structure. Bits do not exist except as abstractions over complex physics, easily degradable physics. Lex interrupts. My question mark says, it's like, what? What are you saying? Joscha says, non-existence might be a meaningful notion. Might not be a meaningful notion. In some sense, if everything that can exist exists, for something to exist, it probably needs to be implementable. The only thing that can be implemented is finite automata. So maybe all of existence is a superposition of all finite automata. So here I just going to, maybe Joscha should read Bergson's discussion of the concept of nothing in creative evolution. Then all of creative evolution, but before that, all of matter and memory. And a superposition of all finite automata. Just what does that mean? I mean, the only thing that can be implemented is finite automata. So a wasp is a finite automata. All organic structures are just finite automata. Interesting supposition. And apparently then we have a horde of Platonic abstract automata in the realm of eternal ideas. I think. That's the implication. Of course, Lex goes, what? Joscha says, imagine that every automaton is somehow an operator that acts on some substrate. As a result, you get emergent patterns. Lex, substrate? What? Joscha says, I have no idea. Some substrate that acts for information. Okay, he can't seriously defend this. That is, he really can't get his math equals the basis of all started this way. Note, automata is a mathematical concept, and he's fundamentally saying math starts the universe. It's the foundation of the universe. We're into the realm of Platonic ideas. So JB and Lex get to talking about when classical philosophy ended. This seems in JB's mind somewhere around World War II. Not sure. What he seems to believe is that the greatest discovery philosophically is the notion of mathematics as computation. Quote, the discovery that the last big thing that works are computations, and it hasn't fully permeated philosophy or even physics yet. See, we're getting to this. This is the basis. This he refers to as constructivism. Lex question, like Gödel? Yes, but Gödel did not get it. Herbert did. He, that is Gödel, thought that in the current semantics, you cannot build a computer without crashing. What Gödel could show is that using classical mathematical semantics, you run into contradictions because Gödel strongly believed in these semantics more than what you could observe and so on. He was shocked. He felt the world had to be implemented in classical mathematics. In that FQX Guy talks, we'll see that he has this slide from Gödel. We cannot build a mathematical machine that interprets all of mathematics. So continuing, for Turing, it wasn't quite so bad. I think that Turing could see that the solution was to understand that classical mathematics was computation all along. For instance, pi in classical mathematics is a value, but it's also a function. It's the same thing. So yes, pi, 3.1416 out to infinity, a value, but it's also just perimeter divided by diameter, function. And in computation, a function is only a value if you can compute it. And if you cannot compute the last digit of pi, you only have a function. You can plug this into your computer, let it run until the sun burns out, and that is the last digit of pi you will ever know. But it also means that there is no process in the physical world or any physically realized computer that depends on having known the last digit of pi. It means that there are parts of physics that cannot be defined, for they cannot strictly be true. Assuming that these could be true leads to contradictions. So this is quite a statement. But I would note, pi is also just an invariance law. That is, I can increase the diameter and the perimeter increases proportionally. Increase it again, proportionally. It's a transformation. The perimeter over the diameter is always a constant. So pi is a feature of a transformation that can be performed. No numbers. I don't need 3.141617 all the way out to infinity to show this, to prove this. No numbers are required for the proof. We can prove this in various ways. So we've got a bit of a interesting, I won't call it red herring, but what we'll see is there's something else going on here. Joscha has just slid by Penrose in his exposition of Gödel. For Penrose, Gödel showed that a computer was not capable of the power of the human mind. And he showed what we've seen before, a proof, a non-computational proof, purely visual proof of a computation that does not halt, the halting problem. As we saw, what he's showing is adding successive hexagonal numbers always equals a cubical number. I start with one hexagonal number. The next hexagonal number is a 7. I fold it into a 3-sided cube, not quite a cube. Fold it over stack it over the first, and I've got a cubical number, 8. Then the next cubical number is a 19. stack that over the previous cube, I've got a cube of 27, etc., etc. A purely visual proof, which he said requires consciousness. This is non-computational thought. It is not something a computer can do. Joscha clearly is assuming Penrose is wrong, a non-factor. For him, computers can equal mind. So he's gone right around this problem. Note, this is the same thing as showing that pi is an invariance law, a constant proportion. The Penrose argument in my terms goes like this. Mathematical proofs are based on invariance from our experience, like the invariance of the coffee stirring. A fold of normal experience is characterized by invariance. And part of that is, for example, that the folding material, if I'm folding that shirt there, part of it stays quite stable as I move. It doesn't disintegrate as features of that event. Or the stacking. Stacking has a certain set of invariance laws that define it. And as we can see, the second stack there is from the left, that's building up on a void with no support is a bit anomalous because you need support for stacking. So something that's supporting the stack is an invariant feature as well. So these form the primitives of proofs. And these invariants are inexhaustible. They're infinite. That is, they cannot be finitely defined. A computational device has no access to the creative source of invariance detection. Why is that? Because they would have to have experience, dynamic experience unfolding over continuous time. For Penrose, this requires consciousness. What I would say is it requires consciousness because this requires an indivisible transformation over time, a continuous, indivisible, not discrete instant by instant time. One has to see the continuous transformation. For Joscha, this is all a say what, not even part of his thought process. Continuing, our experience of the world is not reality. Reality is a mere quantum graph that we cannot get access to. But it has the property that it can create certain patterns for our systemic interface, that is our body and perceptual system, into the world, like the coffee cup, stirring spoon. We make sense of these patterns, and the relationship of these patterns that we discover is what we call the physical universe. At some point in our development, our nervous system, we discover that everything we relate to in the world can be mapped to a region in some three-dimensional space. We know now in physics that this is not quite true. I'm not quite sure what he means here. It is not actually 3D, but the world we are entangled with is largely a flat 3D space. It is a model that our brain is intuitively making. And I think it is what gave rise to the intuition of res extensa, that is extended things, the extended matter, to the material world, the material domain. It's one with the mental domain, he's implying. So what he's saying here is that res extensa is in essence equivalent to the 3D continuum of points, positions, the extended world of the classic metaphysic, which is the basis of mathematics. He says later it's just a class of models that relate to the environment and this 3D physics engine in which we are embedded. So JB's res extensa is an abstraction. It's not real. And yet this unreal abstraction is the basis of his math, his all start. Again, his little awareness of the metaphysic in which he works. Bergson, we noted, in Creative Evolution, said the extended is an ideal limit that is never reached. It is a tendency towards which the creative impulse, that is consciousness, the impetus of the inextensive consciousness moves. As a lessening of force, a tendency that tends to the mathematical form, the matter extended its mathematical order, and thereby the treatment of this as terms of components that we can decompose and recompose recomposable parts that are subject to deterministic laws. So JB is pointing to the same thing of Bergson, but he's not realizing its implications. So continuing, so the big thing is that we don't exist inside the physical world. We do exist inside the story that the brain tells itself. So we exist inside a story that the brain tells itself. Lex says what? Basically, your brain cannot feel anything, he said. JB says. Neurons cannot. They are physical things. Physical systems cannot experience anything. But it would be very useful for the brain or the organism to know what it would be like to be a person and to feel something. We ask, why? A robot has no story. A robot needs no story. Supposedly robots, the epitome of AI, function, that is, they see, they think, they have cognition, just fine, without a story. So why then is this story useful? He goes on, so the brain creates a simulacrum, a person. It uses to model the interaction of the person, the best model of what the brain or organism thinks it is in relation to its environment. So it creates that model. It's a story that the brain is continually creating and updating. He says, I can generate things that create patterns on your retina, but we both know that the world we are seeing is not the physical world. What we are seeing is a virtual reality generated by the brain to explain the patterns on your retina. This is standard indirect realism. JB has no clue how the brain generates the image of the external world. This is magic. And it's an obvious plummeting into the hard problem in its very terms. And we'll talk about that a bit more later. So it's time to go to Joscha's more direct exposition in 2019. We'll weave back to Lex and JB later a bit. We start with this list of paradigms of consciousness, as you see there. Idealism, materialist monism, dualism, panpsychism, illusionism, scientific incompletionism, Mysterianism, which gives up on the whole problem. And a powerful model is missing. Who could that be? Well, this guy's telling a story of himself thinking that Bergson's missing, but I'm asking at this point, why? Why is Bergson's model, which has certainly been in enough journals, not at least a consideration? I'm starting to find this just amazing at this point. But now for the mathematics. His slide beginning with is mathematics is the main of all languages. Constructive mathematics, remember that's the Turing end around, we just compute, the subset of mathematics that can be implemented. So constructive mathematics is computation. He notes Gödel's doubt, as we saw. We can't build a mathematical machine that interprets all of mathematics. He was quite correct on that. And Turing's workaround. Meanwhile, we can build a computational machine that runs all computations. So we're just excluding all mathematics that can't be, shall I say, computed. So he shows this slide, emphasizing AI as a philosophy of mind. But yes, just call it the classic metaphysic, for AI is nothing but the implementation of this metaphysic. And then he makes this statement: consciousness as a side effect of attention-based learning. So we'll save that one. That's one to look at. Then he starts, our perception of the world starts with patterns. And he shows some patterns. And he says, and we merge those into percepts that cover features of our environment. And we can merge all these modalities. The modalities are the bottom purple things, the visual, the auditory, the tactile, etc. The modalities into a simulation, into a perceptual space. And this is what we perceive as reality. So that is this perceptual space holds the image of the external world. That is the coffee cup. External to us, but it's in a perceptual space. What is this? So this is entirely static. He's thinking of static features, but there are none. He's thinking of features like the picture below, the edges, the vertices of a cube. We would break that cube down into these features. But the problem is these are dynamically defined only over time, as we've noted many times. The edges of the cube, the vertices, are discontinuities of flow fields, sharp discontinuities of flow fields. So they're invariants of time-extended events, of flowing events. Each event, like the coffee stirring, has a structure of invariance with velocity flow fields, etc. So we're already getting a bit of magic here, from quite a bit of magic, because JB thinks he can construct everything from a static world, static features. That's magic. So invariance over time, over continuous, indivisible flow. Where will this be in JB's scheme? His machine, computer, moves from abstract state to abstract state to abstract state. State 1 ceases to exist instantly as soon as state 2 arrives. There can never be more than one state. Where can there be continuity to perceive a stirring? He must take his static features that exist in one of these instants, the static features of a rotating cube. He's got to disassemble them into some memory, then reassemble them instant by instant in real time. But as noted, such features do not exist. Remember our discussion of the strobed out-of-phase cube. We strobe that cube out of phase with a symmetry period, a rotating cube, and it becomes a wobbly, non-rigid, not a cube, flexible object, where the edges and vertices are now gone. They're functions of time, of flows. Again and again, whence the continuity that he needs to perceive this time-extended, time-flowing event. And his merging, that is his word for binding, the binding problem of modalities, the optical, the sonic, the kinesthetic into one perception of the coffee stirring with its visual flows, its clinking, its aroma, its feel as we stir. But firstly, JB's machine has no modalities. It has only a homogeneous memory of bits, neurons. But it is invariance defined again over time and change within and across modalities, or flow, that is the very basis of the merging. I've given examples before. When you pour the water into the glass, the acoustical frequency, the sound pitch rises proportionally with the optical rise in the liquid's height. Or again, the optical, the looming of the train engine as an expanding radio flow field as it comes to the observer is coordinate with a wide range of frequency values expressed by the Doppler effect. It is acoustic as it passes by. As we're stirring, back to the stirring, the adiabatic ratio, the energy of oscillation to frequency of oscillation in that stirring. This ratio is coordinate with the inertial tensor that defines it also, with the radial flow, with the acoustical information, the clinking, etc. But there's none of this in JB's model. There's none of these, there's no time flow and no invariance over the time flow. JB's binding is magic. He has no basis for it. Now, the magic really appears. Somehow, the image of the external world arises or emerges from this computational activity. It's the very essence of the hard problem. For Chalmers, how does your architecture, JB, neural, computer, whatever, account for qualia? As I said, this is more generally stated as how does it account for the image of the external world? For the entire image, all its forms, all its colors is qualia. All form is qualia, dynamic form. So here we have a zero of a theory, boldly asserted as a solution. The image just emerges. The image of the coffee cup from or in our guy's brain, or somewhere. We know it actually isn't in the brain, some mental sphere, or yes, the famous perceptual space. What is this? This is just a nothing. What would an actual model of the origin of the image of the world look like? Well, we've seen it from Bergson. This field is a holographic field, as he said in Matter and Memory. There's no photograph in the brain, obviously, but rather the photograph is already developed in the very heart of things and at all points of space. Then, in essence, the brain in Bergson's framework becomes a modulated reconstructive wave passing through this field. Modulation of the reconstructive wave, passing a reconstructive wave of frequency 1 through the holographic plate. And specified then is the object wave tied to that reconstructive wave, in this case a cube. Modulated to frequency 2, now specified as the object wave or source of the object, the cup. Modulate to frequency 3, now specified is the wine glass, the source of the object wave. Modulate back to frequency 1, specified as the cube. So the modulated reconstructive wave is specific to a source within the field, the coffee cup, stirring spoon. Now, to understand this fully, we'd have to bring in, and we will, Bergson's model of time shortly. Again, this is right where it says it is, external, within the field. So back to the Lex and Joscha discussion for a second. In this context, let's ask, what about the hard problem? Why does the simulation feel like something? Remember, these guys are always focused on the feel like something, not the image. JB notes a book, Folks Standing on a Hill, and below there's a city they wish to conquer. I didn't catch the name of the book. To quote, they look at the color of the sky and they're apprehensive and they feel empowered and all these things. And why do they have these emotions? It's because it's written into the story. And why is it written? Because it's an adequate model of the person that predicts what they will do next. Really? And the same thing is true for us. It's basically a story that our brain is writing. It's not written in verse. Continuing, it's the story written in perceptual content. Basically the multimedia content. And it's the model of what the person would feel if it existed. So let's get our story there for our guys on the hill. So it's a virtual person. So they're all virtual persons. And you and me happen to be this virtual person. This virtual person gets access to the language center and talks about the sky being blue. And this is us. And he smiles. So this, the above, is his answer to this, Chalmers' question. What is the origin of qualia? Right. The story is just written in perceptual content, like the coffee cup, somewhere in that famous perceptual space. This is not a theory. Back to the FQXI talk. So he goes on, and this is what we perceive as reality, and it's made up of a model of ourself, somatic self, personal self, social self, and a mental stage, imagination, alternate mental universes we construct. So self now becomes important in the mental stage. And then, in addition, he says we have generalizations over that. That is, we're going to get concepts. And then we add an attentional system, a conductor of this mental orchestra that produces all these representations. And he says the attentional system is able to track the identities of objects. If you don't have this, something we've discovered recently in AI, it's difficult to make certain generalizations. You bet. This seems to be his explanation, however, of this. Consciousness as a side effect of attention-based learning. That is, we're bringing in the role of attention, and somehow consciousness comes out of attentive processes. So somehow attention is more fundamental than consciousness. I mean, The stuff hiding in some of these statements is, I mean, more than I can actually take time to penetrate through. But this is just boxes. The age-old box diagrams of the mind. He has no clue of how any of this works. He cannot have one because he has no theory of perception, of the image of the external world, thus of experience. Perception is not occurring solely within the brain. For Bergson, experience then cannot be stored solely there. JB's generalizations and his abstractions can only be invariants over 4D time-extended experience. We're four-dimensional beings. Coffee stirring is an abstraction over all those experienced events. The brain is and works nothing like JB thinks. It is not a symbol manipulation device working in an abstract time, state succeeding state, instant succeeding instant. Remember this statement. The attentional system is able to track the identities of objects. If you don't have this, well, you've got problems. But features like the features of that cube, the edges, the vertices, are also objects. But the tracking of features problem starts with perception, as we noted. It was termed the correspondence problem. If you start that cube in motion, rotating, and you're treating that rotation as a series of states, discrete instants, you have to follow those features through each frame and maintain the identity of the features. Else, well, your perception dissolves, your coherent object dissolves. But this problem was ultimately deemed intractable. Theorists went to flow fields, velocity flows, and features, the edges and the vertices, became defined over these flows then. An event is a flow. Events are 4D. How are these flows stored? This is a problem of time, for which JB has apparently not much thought at all. Again, solving this problem is yet more magic. So, continuing, we need to add a protocol memory right there. We'll see what that is in a second. Because we also have to add control right there. Attention needs to be controlled. It has a controller. I guess attention is the controller. There's a controller behind attention. That part of your self model that, quote, tracks where you are attending from. In order to make that happen, you have a protocol memory. So now we come to the protocol memory. That is a sequence of events you have attending to in your mind that you are aware of. So a rather four-dimensional extended event. This is integrated into your biographical memory and subjective self. It is what gives unity to your experience, such that you are the same being you think you were yesterday or the moment before. This is fine. You almost cannot argue. Yes, there is attention, there's biographical memory, there's abstract concepts. But this is just more boxes being heaped up, making it look like an AI, a computer, a Turing machine can actually deal with the mind. No matter the implementation, the operative dynamics, whether it be for a robot, whether it be for a modern PC, your iPhone, or Turing machine, the operative dynamics is symbol manipulation in an abstract time of discrete instants, not concrete dynamics. The dynamics of the AC motor is such. There is no theory of perception, thus of cognition or of memory in JB's model. Thus his scheme is utterly ungrounded. It's based on sand. So we see these slides. The environment and body, a primary model, declarative knowledge, knowledge of things, a secondary model, and the self is a tertiary model. And his favorite theme, you are a story that the brain tells itself about a fictional person. He says, the reality that I'm immersed in is not the physical world, it is a dream generated by the cortex. So everything is a model, and the model is a dream. And then we come to this slide. This is particularly interesting. Remembering having been conscious is necessary and sufficient for consciousness. So all it takes, he's going to be saying, is remembering to be necessary and sufficient for consciousness. But somehow remembering isn't consciousness. This is interesting. Then he says, I stub my toe. The illusion is this is immediate. This is a thing that is constructed after the fact. And we live in this narrative generated by my brain. So let's look at this a bit. Yes, we are always seeing the past. Perception is always already a memory. But in JB's framework, static features in the abstract time of discrete instance, as I noted, he has to disassemble, store, and reassemble the features of the rotating cube in real time. And still there can be no continuous perception, only state after state after state, because each state disappears when the next arrives. We only have this abstract dynamics, operative dynamics, and abstraction. But as we've noted, the transformation of the holographic field, the time transformation, is indivisible. There are no discrete instants. Specification, whether it be of the fly, the cup, the coffee cup, is to a past time extent of the field's transformation, because inherently the field has a memory because of this indivisible transformation. And that specification is at a scale of time set by the dynamics of the brain. We can have a buzzing fly, we can have a fly barely flapping his wings like a heron, or we could have the fly basically appearing as an ensemble of electrons. Different time scales. JB would say scale of time. What are you talking about? But scale is qualia. Each of those perceptions of the fly is a different qualitative form, obviously. And scale requires a form of compression of events over continuous time. In the buzzing fly case, we have hundreds of wing beats compressed as a perception. But we can change the chemical dynamics of the brain, and this entire event can be spread out over time. We can start seeing the individual wing beats, or even the electrons underlying each individual wing beat. We're spreading the fly event out over time. But mathematical operations are scaleless. You can run them at any speed. It doesn't matter. It's scaleless. The same dynamics is effective. No matter how fast or how slow you run your computer, eventually you're going to make the computation. Whence scale in AI without complete ad hocness? So it is the indivisible transformation of the field that is the primary memory, as I noted. This memory underlies the narrative, to use his term, of the rotating cube, or the narrative of the buzzing fly at any scale, or the narrative of the stirring of the coffee. That is, it underlies the continuous transformation that's perceived. And yes, then, the narrative of the self. Without this continuity, this indivisible transformation, JB's story, quote unquote, is a fiction that cannot exist. So we come to this remarkable statement. Remembering, having been conscious, is necessary and sufficient for consciousness. Remarkable in its incoherence, just one of many. If you were conscious, why do you have later to remember having been conscious to be conscious when you were conscious? It's like our guy here having to say, I have to remember seeing this cup because else I won't be conscious of seeing this cup. Perception is consciousness. It is a specification of a past extent at a scale of time of the elementary form of awareness defined over the ever-transforming holographic field. This is due to the field's holographic property, where each point reflects the state of the whole. Therefore, there's an elementary awareness at the smallest scale of time already at each point of the whole. And this indivisible transformation that is a primary memory. There is no need to remember. Perception is always already a memory. But this statement, the specification of a past extent of an elementary form of awareness, this is the expression of Bergson's statement. Subject and object is related in terms of time, not space. There's no true differentiation between the body and the field. No true differentiation. There's a practical differentiation or distinction. It allows us to remove the homunculus. There is no homunculus looking at the image. The image is the specification of awareness. So that fly is a form of the awareness, an elementary form of the awareness, the perceived fly. But for JB, that's subject-object relationship, that's a what? Because it's already solved. We only know our habitual story, not the external world. In other words, indirect realism, a form of idealism, and nothing more. So back to Lex and Joscha. Lex voices his intuition with a massive amount of knowledge we need to have of the physical world. Common sense knowledge. But JB downplays it. He says, how much common sense knowledge do we actually have? All your life, say 2 new concepts every half hour, maybe 1 million concepts in our lifetime. 1 million concepts. That is for a machine, he's saying. That's not a lot. I think he's worked this out, this number, because if you take it over 40, 50 years, 16 hours a day waking, it kind of works out to 1 million concepts at 2 every half hour. But the problem is, for example, Doug Lennon has been teaching or trying to load and teach common sense concepts into his psych, short for encyclopedia, I think, system for the last 39 years with a team of people since 1981 without a great deal of success. And the system is surely becoming unwieldy by this time. Take this little sign I just saw coming back from the dentist. Slow down passing horses. Now, all the knowledge required just to understand the normal meaning of that is rather large-ish. It involves driving cars, what it means to pass, what it means to stay on the road, what horses are, how horses can be walking, etc., etc. Then, of course, there's the ambiguity problem, because what it could mean is we're supposed to slow down the passing horse, slow it, lasso it, retard its motion. But then again, we could be having to slow down passing horses in a football game. Now, one could say, oh, the ambiguity problem is unfair. That's more than AI has to deal with. But the problem is, it's the same problem. Because we can easily make up a situation where that latter makes sense. It's a football game with children, but we don't have a football. So we found a toy horse. Toy horse works just well for football. Or our simple coffee stirring situation. The coffee is stirring slowly. There's our sentence. But is the coffee waking up? Is the coffee being stirred by itself? Look at one could drive the computers nuts because they simply don't have the experience. The truth is, a 5-year-old has greater common sense knowledge than an AI. It doesn't take 50 years. It doesn't take 5 years. JB does not understand invariance laws, the nature of experience, the flow of experience, the indivisible flow, its events. As noted, the invariants that emerge over these events are inexhaustible, that is, infinite, and they form part of proofs. That is, there's not 1 million concepts. There's an infinity of concepts derivable from our experience. The problem of the mousetrap. This is the problem we used, number 7, as the exemplar of common sense knowledge, creating a mousetrap of components, pencils, razor blades, rubber bands, boxes, paper clips, string. The features of the components emerge only over the transformations. What I want to do with that pencil, I want it to hold an axe, the razor blade, or I want it to be an arrow, as in the crossbow trap up in the left. Or I need to, the corner works well for holding the pencil, lodging it in place. The rubber bands will serve different features and different functions in each case, with different features will emerge. Same problem as that of Penrose. The brain is a device for accessing 4D, time-extended multimodal experience. JB's device, with its abstract time, with its purely homogeneous representation, not multimodal, simply does not have sufficient representational power not even close to do what he needs to do. So postscript 1. My suggestion for the Joschkas of the world, even for the Lexus, take time out. Study. Study everything by Gibson, also by my mentor, Robert E. Shaw, also Turvey. Look at Kruger and Turvey's book right there, the purple one, Information, Natural Law, and the Self-Assembly of Rhythmic Movement. Study all of Piaget, the child's conception of movement, speed, of space, of time, of physical causality, of reality, on and on, at least 15 books. And study the critiques of the connectionist attempts to reproduce Piaget. Study all of Bergson, Time and Free Will, Matter, Memory, Creative Evolution. Study Wertheimer, Brunner, Montessori, Wertheimer's Reductive Thinking. Study Mark Johnson on language, Lakoff, Hofstadter, and Sander. Let the implications sink in. So let's ask, why is the idea of the self an important feature in the simulation? JB says, so that priors you commit to are largely target values that our needs would approach checkpoints. And this deviation from the checkpoint creates some urge, some sentience, and we find ourselves living inside feedback loops. Like consciousness emerges over dimensions of disagreement with the universe, things that you care of, things that are not the way they should be. This is what, I didn't quite catch the name, I suspect Buddha learned, that the goal of these identifications, of these commitments, is to get free. There is nothing you have to do anymore. And if you let go of all of them, then you are completely free, and you can enter nirvana because you're done. This is well-meaning, I'm sure, but it is the tragedy here. The absurd role appropriation by AI on this flimsy basis as the explanator of spirituality. That is, spirituality is just another illusion, just another story being told. Simply add in a robot, too. They can tell the same story. There's no differentiation. To AI, actually figure out how we see the coffee cup. Get a theory. Believe me, this is well mystical enough and well beyond your machine. Next, we'll see. Till then, signing off.